This is video 492, and the goal is to just continue solving equations to prepare us for our project. So in this example, we're going to look at a couple of things. We're going to be finding some values when we know the t time for this situation. We're also going to be finding when we have a certain population. So first of all, we're finding the initial estimate for question 1 here. Well, the first part we need to understand is that means time is 0. So we're going to put 0 in for t. And then we're going to evaluate this function. Now, it would be super easy just to punch into our calculator, but what's even easier is to know one quick fact about sine, that the sine of 0 is 0, because y is 0 at 0 degrees or radians. And therefore, the 3000 sine 0 just cancels out, becomes 0. So the answer here is 7500. Now, the second question is going to be similarly easy in that we're going to plug in 5 for 5 weeks. But this will be a little bit more work to think about. Sine of 5 pi over 2, because sine of 5 pi over 2 is not on our unit circle, but there is a coterminal angle. Sine of pi over 2 has the same sign as sine of pi over 2. So these two angles have the same sign, and that sign is 1, because on the unit circle, sine is 1 at pi over 2. So this will just be 7500 plus 3000, because 3000 times 1 is just 3000. The answer here is 10,500 grasshoppers. So here's the simple problems. This is what you'll do for your project. You'll plug in points for your independent variable, like time or x, and then you'll solve for your dependent variable, like population or temperature. Now let's take a look at question B. Question B is asking a slightly different question. When is the greatest population size over this interval, and when does it occur? It's a good idea to look at a graph here. If we know simple rules about sine, it peaks at 1/4 of the period in the curve, if it's a normal amplitude, which it is in this case. So what I'm going to be looking for is, number 1, real quick, find the period. 2 pi divided by pi over 2 is 4. Well, how did I get that so quick? 2 pi, remember, is 360 degrees, and pi over 2 is 90 degrees. 360 divided by 90 is 4. So I can kind of do that a little bit quicker in my head by knowing that simple fact. So the period is 4 because I used my b value to find my period. So the good news is this is simple numbers. It's going to go from 0 to 4 to have a period of 4. So in the middle there it's going to be 2, and of course then at the peak it's going to be 1, halfway to the middle. So at 1 week I'm going to hit my greatest population. So now I'm going to plug in 1 for my function to find my greatest population. So I'm not making a complete graph. I'm just using the graph to kind of visualize what's happening. So now I'm looking for what is sine of pi over 2? Well, again, we just did that. Did we find that sine of pi over 2 is just 1? So the answer here is the same as the answer to question A, number 2, and it's 10,500. So why are those both the same at that point? And that's because they're 1 period away. So by knowing the period, those two grasshopper values are the same because they're 1 period apart, and it just repeated itself. So the correct solution to this question is at 1 week, 5 weeks, and 9 weeks, it will hit its peak. And I found those by simply adding periods. I added 4 weeks for a period, added 4 weeks for a period. So that's my solution to the first 2 questions. So those 2, hopefully you find some ease with. They're not too complicated, but we're going to take a look at some harder questions in question C. So now we're asked, when is the population 9,000? So now we're putting 9,000 in for the population, and we're solving. And the first couple steps here are fairly easy to solve. We're going to take off the 7,500 from both sides, and then our next step is to divide both sides by 3,000. But 1,500 divided by 3,000 is just 1/2, so I'm going to simplify that. And I get sine of pi over 2 t's alone. Now my next step is to undo the sign, because it's the outside operation here. It's the next thing I need to undo. And to undo it, we take the sine inverse of both sides to cancel it out. Now this is where it's tricky. You got to be careful here because we're taking the sine inverse, so we're limiting our range. But there are infinite values where sine is 1/2 because of the periodic nature of this function. But we're only going to get one value by punching this into our calculator. So we'll talk about how to get the other values in just a second. So the one value that we're going to get, of course, on the right side, the signs cancel, and we're going to get pi over 2t. Sine of 1/2, the sine inverse of 1/2 is 0.523. Now I'm going to leave that value in my calculator. I just plugged it in. I'm going to leave that value in my calculator because I'm going to use it to finish the problem. I have one more step to solve for t. And I'm going to use that answer to find the exact value. So my next step is to cancel the pi over 2. Well, I can cancel that by timesing by the reciprocal, because pi over 2 times 2 over pi will cancel the 2's and the pi, because they'll be on top and bottom, leaving me with just t. This is a fast way to get rid of fractions that I think many of us forget to use. Now, of course, I'm going to do that on the other side as well. I'm going to times it by 2 over pi. Now, in my calculator, that means I'm going to hit times, and it'll take the previous answer, 0.523, 2 divided by pi. If you take that previous answer, you're going to get the exact answer for t, which is 1/3. Your calculator should give you 0.3 repeating if you use the exact answer for sine inverse of 1/2. So the time is 1/3. Now that should make sense based on that graph we had drawn earlier, where we had that peak at 10,500 at 1 week, remember? And then at 9,000 be just a little bit below, so a little bit back in time. And that's a little bit smaller than 1. Now what you should also notice is there's a second point that's 9,000. So how do we get that second point? We're going to go back to that step that I pointed to with this arrow here. We're going to go back to that step because that's where we limited our range to only finding the one value right at the beginning there. So our second value will be found by simply looking for the other angle who has a sine of 1/2. And that other angle is pi minus the answer I got when I found that angle that had a sine of 1/2. That's always what we'll do at this step. When we're doing the inverse of both sides, we have to consider two angles. The angle that we're given in the calculator and the angle that's pi minus the answer we're given in the calculator. Those are my two angles. So I'm basically finding the same exact step as we see in the boxes there. Hold on. Sorry, this is going a little too fast for me. So what I wanted you to notice here at this point was that we're taking this same equation that I just circled in the box. It's the same equation on the right, but all I did on the left was I changed the angle values. So instead of 0.523, it's pi minus 0.523. It's the other angle in radians, of course. Now I'm going to solve this equation the same way I did the other. So I'm simply going to times both sides by 2 over pi. I get the decimal. I'm going to leave the decimal in my calculator, and I'm going to times both sides by 2 over pi. Again, I'm doing this in my calculator to keep the values exact. So I'm timesing the previous answer by 2 divided by pi. And I get 1 2/3. You should get 1.6 repeating in your calculator, which is 1 2/3. Again, looking at that graph, that seems about right because it's a little bit less than 2, but it's to the right of 1, so it's a little bit bigger than 1. So that should make sense with your graph. So I found my two values for when the population was to 9,000. I could go on and find even more values because they continue and repeat every period, right? So it could be at 4 1/3 weeks. 4 1/3 weeks. It could be at 8 1/3 weeks. I'm simply adding a period to this original time that I found. And I could keep doing that to find infinite number of values. I can do the same thing with this value. I can add on a period. 5 2/3 weeks. 9 2/3 weeks by just adding a period. Remember, our period is 4 weeks. So those are the way we find infinite values. But just finding the first two is all that I'm looking for you to be able to find, especially for your project. So now you're ready to try some on your own. So your checkpoints for today are actually the rest of these problems for this situation. So you're going to try and repeat the process that we have already done. And your free response question is to find those two values for 6,000. So just like we did for 9,000, you're going to do the same thing for 6,000. Find the two times where we hit 6,000. This one's a little bit different because you end up getting a negative value to first, but don't forget you can add on a period to make it positive because that same value will occur a period later. The next question, your multiple choice question, is question D here. So during what time interval does the population size exceed 10,000? So it's very similar to your free response, very similar to 9,000, but now you're looking for when it's 10,000. You're looking for those two times where it's 10,000, and it's one of these 4 intervals. Okay? Do your best. Try to figure this out. If you use your calculator, that's fine. Remember, we can use our calculator to estimate by tracing on the graph and tracing in the table and looking for where is this interval. That's fine. That's a good strategy to know. But make sure you make that clear in the checkpoints so that I know that you used your calculator and that you need more help with solving the equations. So good luck. Complete those checkpoints so that I can give you some feedback.